In class, we looked at the three element shortcuts. We determined some that did work. We determined that the AAA did not work because you could actually build a triangle where that was true, but it would be a different size. We want to make sure everyone's clear on the SSA. So let's take a look here. I've got two sides and a non-included angle congruent to two sides and a non-included angle here. These angles correspond to the right place. And you'll notice that I can extend this side as long as I want, no restriction there. This side has to be that same length because it's set, but I can pivot it so that this angle D changes. You'll notice that right there it appears to build a triangle, but the triangles look like they are congruent. However, if I continue down here to about that point, you can now see that I have still maintained the requirements, built a triangle. I can just shorten this F right down to there. There we go. And it's obvious these two triangles are not congruent. Therefore, there is a counterexample to the SSA because it is ambiguous. You've got two triangles that could be formed, that one and that one, and therefore the SSA is not a valid shortcut. I've had some students, when they discovered this, they will say, oh, we know why this one's not supposed to be valid, because what if a student wrote it in a different order? Well, that may help you remember that it's one of the invalid shortcuts. We also looked at the angle side in class. We determined it worked. I'd like to talk about another reason why it has to work. If the ASA works, which we determined it did, then I maintain that the AAS has to work. And here's why. Because if two angles of one triangle congruent to two angles of another, I automatically know that the third angle of each of those two triangles is also congruent. We know that because of the triangle sum theorem that we developed earlier. So if I knew that other angle, I could put it right here, because if this side is not included between these two angles, it will be included between that unknown angle that we now know is congruent. So I could put it there, and now all we have is ASA. So in a sense, this AAS could be a corollary of this one. Works. However, it's important to note that the corresponding side should be used. For example, here I've got two angles and a non-included side. The non-included side is hooked to angle D. I've got those same two angles and the non-included side. So the only way that this triangle could be formed would be make it congruent. However, let's take a look at when the side is non-corresponding. In other words, I still have two angles and a non-included side, this 2 tick, and two angles and a non-included side, this 2 tick. But notice, this side with 2 ticks is attached to angle F, whereas this one is attached to angle A. And try as I might, well, it's obvious there that those two triangles are not congruent. And so it's important for us on all of these congruent shortcuts to use corresponding parts.